Hi, my name is Luke. I'm a Field Applications Engineer at Salego. In this video, we're going to look at GreenPAK's 8-state asynchronous state machine, or ASM. But first, what is a state machine? A state machine is a method of modeling a system that acts in one way or another depending on what state it is and what input it receives. Think about my pen. It has an input, the clicker, an output, the ballpoint, and it has two states, extended and retracted. Many things can be described in terms of state machines, making it easy to communicate what a design is doing and how it operates. Let's look into the GreenPAK Designer software and check out the ASM. In GreenPAK Designer, you can see the GreenPAK ASM. States are labeled in white. Inputs are on the left side, and the outputs are at the bottom. If you double-click on the state machine block, it will take you to the state machine editor. From here, you can see all the possible states on the right-hand side. You can add more states or remove them by clicking on their boxes. You can label states by selecting a state and editing its name in the left Properties panel, or you can double-click on it to open an editor. I've created a state transition diagram for my pen. The ASM will always power up to the red state, which is the reset state. From there, the pen can be either in the extended or retracted states. Let's add a state that flags the user when the pen has run out of ink. In order to do this, I'll add another state and label it as out of ink. From here, I'll set a link from the extended state to the out of ink state. Now that we have a transition from extended to out of ink states, let's go back into the designer and see what's happened. As we go back to GreenPAK Designer, we'll notice that a new input has appeared in the state machine. In the designer window, you can define which signals enable state transitions. I have two edge detectors, which output a high pulse on a rising and falling edge of my toggling D flip-flop. When the signal is high at these inputs, the ASM transitions, given the state it's in and the active high of the transition signal it is enabling. If we want the ASM to go to the out of ink state, we will add a signal that drives this pen to a logic high when we want to transition there. Let's suppose our pen has an ink detector that drives the input high when the pen is empty. We can tie that signal to the transition enable here to enable the ASM to switch the empty state when needed. The last concept to cover of the state machine is its outputs. The outputs are seen at the bottom of the state machine, and there are 8 output lines. These outputs are fully configurable to drive either high or low for any output per state. You can configure the outputs in the state machine editor. By double-clicking on the state machine, it will bring up the editor, where on the top right is labeled the connection matrix output RAM. This table shows the configuration of each of those 8 lines for the 8 states. You can configure these by toggling the inputs, and there are a few bulk operations. These outputs on the matrix can drive pens or external circuitry. This was a very simple design to provide you with a basic understanding of GreenPAK's 8-state asynchronous state machines. However, a much more complex state machine can be implemented in GreenPAK. A GreenPAK with ASM can equal up to 100 lines of standard C code written for common 8 and 16-bit microcontrollers. For more information on our GreenPAKs, visit us at salego.com.